Hello. Hey, that sounds like sound. Hello. There it is. Let me just adjust. So pretty much I've been talking for the last 5 or 10 minutes or so, and not, not saying anything. So there's going to be a lot of me staring at a camera and not having anything to show for it. That's all right. I can go through it again pretty quick. Basically, what happens is that when I spec'd out this computer, I made a few mistakes. Mainly, it's the memory. What I found just about 20 minutes ago is that when using an Asus TRX 40E gaming motherboard with the 64-core AMD Ryzen 3990X CPU, memory will only work at its stock speed. So last time when I changed the settings in the BIOS to the DOCP setting, and I was talking about how that's how you get the memory to work at the best settings, that is correct. Unless you have this motherboard and CPU combination, in which case the memory can only work at its base frequency, which is about 2133 megahertz. So I'm talking to the person who owns this computer, and I'm waiting to hear back from them about whether they want me to get a new motherboard, which means we could get the most out of the RAM, or if they just want the computer sooner, in which case his application that he's using, NAMD, it uses RAM, but the RAM speed's a lot less important than the number of cores. So he may just want it. You hate to spend the money and not use it, but them's the breaks. The other thing that I didn't like about the build, I've been thinking about this for the last few days, is that I had the radiator at the front blowing air in, and I didn't at first think that I could fit the radiator up top, but the more I looked at it, the more I realized I totally can. And also I'm going to be rotating the heatsink itself so that the lettering is the right side up. That's not that big of a deal. This computer has a door on it, but I figure if I'm going to go to the point of taking the whole thing apart, I should really do it right. So since it's apart, let's do it. What I was saying right before, Nick so helpfully pointed out that I had my microphone off. I usually clean off one of those little tear open packets and a paper towel. It's not the best solution. Ideally, I would use like a lint-free cloth or some Kim wipes or something, but you got to use what you got laying around, and here it's a little more limited than in my office. So another thing that I'm going to do, which will be a little non-standard, is when I go to put this back together, I'm actually going to put the thermal grease on the water block itself rather than on the CPU. And the reason I'm doing that is that the CPU is so big that it's hard to figure out where it's supposed to go on this. So I figure I'm just going to put it on here, slap it together, and it should be good. I did this on Friday last week, and that actually worked fine. When I just pulled it off, it looked like there was plenty of grease there, so all is well. But it necessitates taking the radiator out, the fans. I've got to flip the fans. I had to take the water block out. I've got to remount everything. But I think that when I get this mounted up top, better airflow, and I think that's going to be a much better setup. So with that, I've cleaned off the heatsink, I've cleaned off the processor, and I'm going to get back to work here. I'm actually going to remove the stick of RAM that I had in there earlier just to give myself a little bit more room, and we'll make ourselves a couple of piles here. It's funny too, because like on the Asus site, they don't mention anything about RAM speeds until you go to the CPU support list. There's just one little note that says 3990X RAM runs at stock speeds. And it's like, I checked the qualified vendor list. I checked the qualified list for the power supply. I missed checking the CPU because there's only 3 CPUs that the Threadripper socket supports. I didn't think it was going to be something I really had to worry about, but that's bad on me. Fair. And there's fixes for that. So hopefully, the guy who's getting this machine will be pretty forgiving. I'm not too worried about it. I know him pretty well. He's a nice guy. And I think that by flipping these fans, getting the radiator up, I think, this machine's going to be just really beefy anyway. So whether we lose a gigahertz on the RAM or not, it's not going to be the end of the world. It's more a matter of how fast do we want it? Do we want to try and go through an RMA process? What do we do? Well, apparently I missed a screw last time also, so this is extra good to go through this. Nick, how are things going for you? What's new in Nick land? Good. Hanging in there is good, especially in these unprecedented times. Everybody says it, and I think even everybody says it like it's a joke, but I'm still sick of it, but I still can't help it. I'm like, I have to say it too. Everybody else is saying it. Getting ready for school, new job is fun. What are you doing for your new job? Yeah, I also can't wait to live in boring times. I would be all for boring times right now. Boring times, hanging out and seeing people, going to Quarters Arcade up here in Colorado, or the one up down in Denver. And any barcade would make me pretty happy right now. Ooh, excellent, high-speed ad delivery. So is this high-speed into my my mailbox unsolicited? High-speed ad delivery. That sounds awesome. Do you work with a hero protagonist? I know he's more of like a pizza guy, but that would be pretty awesome. I do want cute cat videos, so I'm willing to watch some ads for that. That's awesome, though. Congratulations. I'm glad you're enjoying it. So I almost made another mistake here in putting the radiator back together. It's going to flip upside down from the perspective of the table, and the cables need to come out this side so that they go out the back of the case without having any goofy routing. That's fine, easy enough to do. Why this radiator? So this radiator is the Asus ROG Strix 360. Let's see, Asus Ryujin, that's the one. It's a 360 millimeter radiator, and I specifically chose this one because there's a fan integrated into the water block. Nobody else really does that, and at least if you believe Asus's marketing, it does provide some extra cooling. If all the components around the CPU don't get much cooling, because if you put a water block there, instead of having a fan blowing down and kind of spreading out from there, cooling off components, you just don't have that. So it seemed like it's a good one. I knew that I wanted a big radiator because we want this to be as quiet of a machine as possible. So we want to be able to handle the biggest heat load that we can. The AMD Threadripper 3990X is rated for 280 watts of heat output, which is just bonkers. So I'm actually, I'm looking at this radiator. I'm like, well, it's a big radiator. It's got big fans. Is it going to be enough? And I think it will. I've had the computer on, but I haven't put it under a full load. And that's part of the reason that I'm also flipping the fans. I want to get just as much cooling as I can get in there. We can always turn down fan speeds later if it's too loud for the user, but adding fans is a lot more invasive afterwards when it's in his house, in his office, and I have to go in there with nitrile gloves and the socially distant face mask and everything else. So I figure if we get in there, we flip this around, we add a couple more fans, hopefully it'll be a nice computing experience while he's doing whatever molecular dynamics simulations he does. And I have a test one. It's interesting. The the way that they measure sort of speed of this simulation is you run the simulation and then you see how many nanoseconds of simulation have you completed in a full day. So when you start looking up benchmarks elsewhere, it's nanoseconds per day. And for doing this kind of thing at home, once we get the 3080 Ti's, that'll be more helpful. If I understood right, I tried to run a benchmark last week. On the CPU alone, it's between 3 and 5 nanoseconds per day. When we add the GPU in, this Quadro P4000, that got it down to about 1.5 days. Let's see, 1.5 nanoseconds per day. But I may have been doing it wrong. I don't know how to run the software. I just kind of found a quick guide. There's a command line option you run, and it runs for a few minutes and then it spits something out. But the computer didn't get loud at that time, which was great. But I still think this is the right way to go. The other fun part is going to be, where do I put all these fan cables? This would be a good time for the overhead cam that I had last week, but it's a little too dangerous with the fancy light above. And I'm feeling pretty good about this at the moment. So I'm gonna stand and try to get some screws in the radiator here so that I don't have to hold it and you don't have to be staring at my waist this whole time. Seems like it is a beefy base. It can be future upgraded with a lot more RAM and GPU. Yeah, that's exactly what we're going for. This molecular dynamics simulation package it's actually hungry for all cores, whether they're CPU or GPU cores. It'll take anything you can give to it. So really, we wanted to get the best CPU we could get in the short term, and from there, next month when NVIDIA announces 3080 Ti's, our plan is to add a couple of those in, and that should really just complete this machine. Ooh, a nice feature of this case that I just noticed. So this case is a Phanteks P400S. And I've liked Phanteks cases the last several times that I've built with them. They're just really easy to build. They're very nicely put together so that you can be very efficient when you're building. But on the top, there is actually a plate that can be removed, and I'm going to do this, that has the mount for the radiator. So I can do this on the table rather than do it standing halfway and letting everybody stare at my waist. But then, of course, I have to bring all the cables through. I've got to bring the fan cables back through, but this is a much nicer view for working. So it's a plate that kind of rotates in, and actually they've got some nice clips along the top for cabling. It's just 2 thumb screws up top. This is clever. I like this a lot. And it's not too big of a case. It's not really all that ostentatious or anything. It's nice. But yeah, I'm really excited for those 3080 Ti's. I'm hoping that we won't have to buy a new power supply. This one wasn't cheap, but it was also kind of the best option for what was available for immediate shipping. And it's beefy. It's a 1200 watt power supply. But I kind of did some looking around for how much power do 2080 Ti's use or 2080 Supers, and if I did all my numbers right, this build plus 2 2080 Supers would be about 80% of 1200 watts. So I'm hoping, that NVIDIA has some kindness on our wallets and we'll keep things going with the existing power supply. Can I stagger powering up the GPUs? Unfortunately not. This power supply is not that cool. If it had some sort of smarts, maybe that would be a lot of fun and a really nice option. I'm sure there's somebody out there that does it. It probably doubles the price of the power supply, but not this one. So I think we'll be Typically, NVIDIA's been much more power efficient lately with their upgrades. So I think 3080 Ti's should be a little more efficient than even like a 2080 Super. Here's hoping though, it's also going to be the first generation of their, was it Ampere release of cards. I really hope that they're just more power efficient, but we'll find out. September 1st is the Magic NVIDIA day, so we'll see. I've had a few people at work ask about AMD chips for OpenCL, but most scientific software works with CUDA better. Okay, so now I'm going to tuck this guy back in. I'm not, well, I have like this this need of like, well, there's holes here for cabling. I should definitely use those to route cabling because they're there. But I think, you know, if I'm just going like up and, well, I don't know, because this is just going to come, I guess, right down in the back here. So it's really kind of not worth it, but it's a really nice feature and I appreciate that they added it. It's just not what I need at this moment. So I'll drop that bad boy in, get those cables out of the way. We'll stick some fan cables out of the back of the machine and also not in each other's way. And then I'll flip it around and I'll manage it all on the back end as well. It's just easier to work back there and you can hide all the cables out of the way. So it's nice. Hey, there we go. And the plate is back in place. Get a couple of screws. And that looks a lot better. We'll be exhausting straight up rather than exhausting into the case. We'll draw more cool air in. Even though the video cards will be nice and hot, I think that'll be better. And then the other goal here is we want to get the water block to face this direction, which means I need to rotate this fan bracket 90 degrees. But I have to go the other way here. Get these tubes out of the way. Like, they're pretty robust tubes. I started using these all-in-one water coolers a couple years ago now, and I really like how robust they are. They feel well together, because I'm always like afraid, right? If I build my own water cooling setup, I'm just going to spill water everywhere. I'm going to do something wrong. But I feel pretty confident with these. Mostly I use Corsair ones, but this one from Asus, like I said, it's the only one with a fan integrated. It's kind of hard to see, but there is a little bit of space in there, and there's a little fan. And I haven't heard it. It hasn't been loud. So, okay. So, kind of the main chunk is done. Now we're going to mount this back in place, and like I said, I'm going to throw the thermal grease right onto the water block itself. I'm using Noctua's NHT H1 premium grade thermal compound. It just comes with most Noctua fans or Noctua equipment, and I had some laying around, so I'm going to use that. Kind of clean this off a little bit with the thumb. That's probably a big no-no, but oh well. And I'm going to use a cross shape here, and probably a little more than I would normally use. Well, maybe not. I may have just run out, actually. I think I've got another tube down in the basement. So there was a video not that long ago, it was going around Twitter, of somebody had taken a CPU and they put some thermal grease on it, and then they had a clear plate that they smushed down onto the CPU. And normally you do like a little sort of grain of rice size thing, or like a small pea, and it spreads out, makes a little nice circular shape. Well, then somebody went and did like an X shape, and it's just spread perfectly to the edges of everything. It was like revelatory watching this animated GIF over and over. And I went, well, I'm going to do that at least on really big ones. But at the moment, I've only got one line of my X, and I'm going to go have a quick trip to the basement. So I'll be back. You'll be able to hear me though, so I'll continue to mutter to myself. 21 minutes. And hopefully I've got another tube down there. I usually do, but we'll find out in just a moment. Just gotta get out of the way of the angry bears. Hey, look at this, not one, but two more tubes, and I will grab them both just in case. I order enough Noctua stuff and Noctua coolers that I end up with all sorts of tubes. I also like to use, I've got that at work, not here. And I've never got into the liquid metal cooling. Somebody gave me some, and I thought about it. I thought that would be a lot of fun to try using, and then when I started reading about how it can corrode some metals, I said, you know, I'm just rather be safe than sorry. So hopefully there's still some in here. There is. Great. And this isn't like the prettiest application of thermal grease, and it's probably even a little too much, but it's just such a big CPU. So I'll save that one for later. And now I don't know which one is the empty one. I'll have to go back and watch the video later. But we've got tubes. These tubes are going to come off the side. I've got a screwdriver. We have one AMD Ryzen Threadripper 3990X. Let's cool this bad boy again. Just line up the screw holes. Hopefully they didn't get... There's like this weird rotating mechanism. I'm going to try and show it off here. All right, let's see. So I guess this fits a couple different sockets, or maybe there's like, it might fit I think there's a different Threadripper socket as well. So it just rotates, and in the process of unscrewing it earlier, I removed it a little bit. So let's flip this around. There we go. I think we are ready to go here. Just get a little bit into the first screw hole, a little bit into the next screw hole down here, and then, as is the way, we'll go in a nice diagonal pattern to make sure to try and evenly distribute the load of pressure as the heatsink goes on. This computer's rocking a little bit. There we go, that's better. Go all the way in, that one, done. It feels like a nice fit. The cables are mostly okay. They're kind of curved in a way that's maybe not as visually appealing as it was before, but I like this layout better. I think this is the right decision, at least as long as the RAM fits in. That first RAM slot would be unusable in this, but we're probably not going to fill up. I've got 4 sticks of RAM. We probably won't fill up the other 4 slots. So if we ever do, then I can go and I can undo this again. But 64 gigs is a lot of RAM, and I'd be pretty surprised if we needed to go and use all of that. So now I'm going to feed some cables around. I'm going to do kind of the same strategy I did before, where I fed cables behind, like right behind the RAM slot tabs, and then around this cooler for the power delivery, and also between the power connector for the motherboard. It really kept the cables out of the way, and that felt really nice. Plus it looked all right too. I'll also have to make sure I don't pinch the cables when I'm installing the RAM, but they're pretty flat, so I'm feeling pretty good about that. That's like 6 slack tabs of RAM. Hey now, 7. Or alternatively, 3 Chrome tabs. I've got a couple of computers that are not like the worst computers, but they're not the best. They're pretty ancient, and if I try to open Chrome in my email, it's just not functional. So it's like, well, this machine has reached its peak performance. The downside to rotating the cooler the way I did is, instead of getting some of the cables off one side and some off the other, they're now all coming off the same side, and that's going to be a little bit harder to organize nicely. But that's what part of the puzzle is figuring out how can we make this as nicely organized as possible with this otherwise giant rat's nest here. And that one's out of the way. And then finally, the lowest cable, but also the longest, the tab for, I'm sorry, not the tab, the header for this is a USB 2 plug that will go into the bottom of the motherboard, and it'll relay data back from the water block into the system. This will be a Windows machine. The Threadripper 3990X runs a little bit better under Linux, but this user is definitely a Windows person. He may get feedback from some of his colleagues that he should definitely switch to Linux. We'll see. I'm happy to help him, whatever he chooses to run. But I'm setting it up as Windows. This is Windows 10 Enterprise, or at least it will be. There was some early, if you start looking into like, oh, Threadripper, should I use Windows 10 Pro? People will start saying, oh, don't use Windows 10 Pro because it can't handle it. And that all links back to, I think it was either an AnandTech or a Tom's Hardware guide, where they had done some benchmarking of the 3990X and found it ran slower under Windows 10 Pro, and you definitely need Windows 10 Workstation Pro. AMD quickly got out and said, no, they screwed up. And for us, with our license from CU, it doesn't matter. We get Windows 10 Enterprise, which is the superset of all versions of Windows. So I think we should be getting the best performance we can get out of this. The program that we'll be using is NAMD, which is this molecular dynamics simulation. And NAMD runs best with hyperthreading disabled. So even though this can do 64 cores and 128 threads, the best way to run this software is with just 64 cores as is. So we're going to do that. Let's see here. The correct way to seat RAM in this guy is to throw it in slots A1, B1, C1, and D1. And so you have four sticks of RAM. It gives you quad channel support with this chip, and you get 2 on each side of the processor. So I'm going to do that now while it's nice and visible. And then I'm going to finish routing that USB cable that I didn't route because I really want to go on the back side of the motherboard so that it looks just nice and empty inside except for the components. That's kind of how I prefer to do things. Then 2 more fans to mount. Then we run Cinebench or whatever. I could do Prime 95 with more tabs than anyone will be able to see. You know, this one I think I'm just gonna have to do over the top. It's not flat like the other ones. I could go down and out the front. That's also not bad, but then you run into getting near the video card and running another cable out. So I think kind of just the best way to handle this is going to be to tuck it over the top, come around the back, pop in the bottom, and then back into one of the USB headers. I prefer the way this is set up. It's already connected into the water block. Some of the Corsair coolers, you have like a right angle USB plug, and then it comes out like over here or somewhere strange, and it just never feels great. So if we go to the back side of this monster, just do a little bit of cable management. And here's the power cable for the water cooler. And the power connector that I used before is not quite long enough, of course. Kind of worried that that was going to happen, but I think I left myself a little bit of extra. Oh yeah, tons. It's just going to be a matter of how do I make it look kind of nice now. But I think if I kind of tuck it off to the side, squeeze in behind the lip of the case. It's not the prettiest thing in the world, but the next person that ever sees this outside of anybody who watches this stream will be me. So I can feel okay about it in the future. Not showing off for anybody else but me. I guess Tom might see the back of this when he, if he wants to add in his own 3080 Ti's or because he'll need to get the power cables out, which I pre-connected. I'm actually, of all like the little one-off decisions I make when I'm building a computer, on Thursday when I did the initial stream, that thought of like, I should probably just pre-connect these power cables now. I think that's going to be the smartest thing I've done in a long time. Otherwise, these cables go, they end up in my office, you know, they're never seen again. Yeah, let's not do that. And of course, there's plenty of cable, so I can run it through all of the existing not zip ties, Velcro loops. And I already loosened them up from when I removed this the first time. So not too much longer here. Boom. Boom. I guess I could probably like undo these entirely if I really wanted to make it nice, but I think this is gonna be plenty good. I will tighten them though. Get some good Velcro ASMR going here for all you Velcro lovers out there. Just the way Fantex does all this stuff with the pre-connected, I'm a fanboy. I don't like their small cases, like their mini ATX or micro ATX type stuff, but this size, their cases are just kind of great. Oh, and I've lost a screw, and I know where this guy goes because I knocked it off last time. There are these covers for like the cabling, just to kind of clean up the look, and they have a little thumb screw to loosen up a little bit. Okay, so for the AIO, we've got one fan, we've got a second fan and a third fan, which will be the one controlling the speed of all the fans due to having all 4 pins, whereas the other ones do not. And kind of loosen this, shove all the cables in here as nice a way as possible. I probably won't have any like thermal benchmarks to say like, oh, changing the fans around the way I did is definitely better. And you can see here because there's 3-degree temperature difference. I'm not going to focus that hard on it, honestly. I'm just going to kind of think that it's probably better. And if the user, as he has the computer and he goes, man, this thing's really loud, and or man, this thing's really hot. Why is my office, extra hot? I'll say, well, you've added, half a person in the room in terms of a computer here. So it'll be fine. Got one more Velcro cable loop here so that I can feel good about it, because we're going to go in this second hole down here. That'll be the closest to the front. Go loop back around this little tab. I don't like the way that lays. This is like always the most fiddly part for me. It's like, oh, let's plug it in and unplug it and plug it in and unplug it. And then I finally get something that I'm pretty happy with and I go, yeah, this is great. And like I said, nobody's ever going to see this again. I'll be the one that sees this when this computer gets decommissioned in 5 or 10 years or whatever. Although this guy, I don't know, this guy could live on for a while doing something. All right, that feels quite a bit better on the back there, and I'm to the point where I will make the mistake of putting the back cover on this. Done. And I say that's a mistake because I haven't plugged the computer in and tested it yet. I'll probably need to do that still. All right, so we've got the way past camera here. We've got the front panel, and I'm going to put the top panel back on. Which just, this whole case, it just goes together so nicely. I promise I'm not actually sponsored by Fantex. I'm just talking about them a lot because I really like this case. And now, let's have a peek here. Put these fans back in, and these are going to be intake fans. But I also want to make sure to get them nice and low because I want to definitely hit those video cards once we buy them, once we can buy them, which of course NVIDIA will be sure happily take our money for Founders Edition cards, which I guess those I wouldn't be surprised if those ended up being like sort of $1,500 a piece. That would be a little more than we were hoping to spend, but yes, I think we'll end up getting them. I know we're at least planning on 2,400. That would be 1,200 a card, but we'll see. We'll see. Time will tell. Okay, fan screws are always clunky. It's like if they're new fans, you're just like chewing into the plastic. But it's just like a really old standard of screw, and everybody still uses it, but that's all right. It works. Although lately I've had a spate of fans in cases in computers at work that were put in with the like rubber plugs that typically Noctua includes, and those all rot over time. You take one of those computers, you stick it in a computer lab for a few years, and then it rots, and you've got problems. So most labs are so loud you can't hear anything except for the experiment stuff, vacuum pumps and whatever else. So if there's a fan vibrating in a case, most people aren't going to hear it. So these days I just kind of go back to fan screws for everybody, and then I don't get computers with fans dangling on $15,000 oscilloscope cards in the future. People going, is this a problem? Let's see. So there are these plate covers I was talking about a few minutes ago. Just sliding a couple of those back if I can, just to make some room for fan cables. This one, I don't know, it kind of looks a little better on the front if that's closed that way. Oh, okay, so the USB 3 connector is kind of in my way now. And really all I need is to get a fan cable stuck through. Doesn't need to be much, and there's plenty of cable to work with. Look at that. Got it. Okay. And again, I'm having these fans blow. You can see from the shape of the fans, they're going to scoop air, push it in. And that'll be better for cooling, I really hope. There's a nice front cover for this case. It has a magnetic door that can be removed, but it also has some really big side vents. And we'll see how it performs. I know the focus, because this is going to be in somebody's house in the meantime, the focus is keeping it quiet. But I think the focus is also on ripping some threads, man. Getting some numbers computed, doing science stuff. I'm just the guy that builds them. I turn them on, I install Windows. I wish I knew what I were doing beyond that. I could really start reading up on molecular dynamic simulations, but I've got other things going on. Okay, so we now have fan cable, 2 fan cables coming over here, 2 chassis fan cables. I'm tempted to, there's let's see, 2 headers on the bottom. I think I had a Y cable that came with the with a different Noctua cooler, but I don't know if I'm going to use it. I think I'm just going to use the 2 onboard headers, and we'll call it good. I just want to slide these guys into place. There we go. Cover up some of the ducting, but also line them up so they look nice when you open the computer so you can see the science happening. And of course, this will be more Velcro fun times, but I'm aiming for the back here. Oof, forgot I put the door back on. I knew that was going to bite me. Hopefully I didn't just gouge the table. I definitely didn't. And since we've already used a lot of the Velcro over there, we're just going to tuck these right here, go straight down, go straight across, and like the other cable, I'll go behind. No, why don't I take that back off until I'm done here, like a smart person. There we go. Do that, do this. Boom, so these will just come straight across. Tuck that in. And if I remember, those are the tabs right there. So we'll do one more. I got caught behind the USB 2 cable from before, the one from which I didn't connect. So this is sort of triply good that I'm getting my grubby hands back in here. It was connected earlier, it's just not connected right now. And we can take the extra cable and kind of bunch it over here. Can loop it in this guy, these two. Just what everybody is coming to watch, cable routing. Oh yeah, that's what all the kids like. We try to do all the science as much as possible, as long as it's atomic, molecular, or optical physics. That's kind of our jam. But we do pretty good at it, is my understanding. So I love being in that environment. Like I'm not a scientist. I kind of like, in retrospect, as a kid, I wish I had been. But as somebody who supports science, I feel really good about it, and I enjoy talking to people and finding like what kind of crazy experiments are they going to do? Can I understand anything at all about it? Maybe a little. I know what an interferometer is now. Although I guess I knew that from astronomy a little bit, but you can make an interferometer with lasers. And if you get really crazy, there was a guy, he has since left our department, but he made an interferometer out of interferometers. So it was like 8 lasers all in sync with each other. It was pretty bonkers, but it was a very sensitive instrument. I went to his talk that was supposed to be on the level that us mere mortals could understand. And it was for about 5 minutes. And then it was not. So, what are you going to do? Okay, we have 2 case fans plugged in. Tuck the cable out of the way there. I'm just going to Velcro this on the back. So no need to get too crazy here. I don't need to be pulling the computer around again. But I am going to tuck the cabling, excess cabling out of the way. I like to keep cable cleanly routed when I can, so that way if I have to pull something out, and I will pull something out later, it'll be okay. So just from my anecdotal evidence, but of the computers that last in our building the longest, and computers in my department don't leave the building unless they are just absolutely not functional. I will always find a use for something, I don't care how old it is. And so that has led to situations where like we'll have a Windows 98 computer still doing science for somebody somewhere. I don't remember if that's true anymore. But definitely there's Windows XP still going on, tons of Windows 7, a lot of Windows 10, fortunately. But like we just have these ancient machines. But anecdotally, the parts that I replace the most, and this is going to be a function of our building, which has kind of mediocre power sometimes, are power supplies and video cards. Typically, people want more screens. You know, how do you know if you're doing science if you don't have an array of like 2x2 monitors showing everything that's going on? Power supplies, we have a lot of power outages. The University of Colorado supplies power to our building, and it's generally quite good. But my department has the dishonor, I guess, of being the highest power consumption building per square foot on campus by a large margin. And it turns out that we have a lot of vacuum pumps, and nature abhors a vacuum, you may know. So they use a ton of power. We do a lot of science under vacuum for years at a time, even. The Cornell group had a vacuum that I think they didn't break for well over 10 years or something like that. CU may have shut their gas turbine down, but they do have a big power building just a couple buildings over from us, and they still use it, or something is still getting used there. I don't know what. I know that they don't do the steam pumped through the pipes under the sidewalks anymore. So in the winter, it's not nearly as nice to walk and have like that row of, steam melted snow out of your way, but that's all right. I'm sure it was an upgrade of some variety that made sense. But the power building is still in use. And actually, they built a second power building that is over by Kittredge. It's kind of on the south end of campus. And I'm pretty sure that's a power building. All right, so we have the front panel on. And here's that cover, or here's where it goes. I've got a nice, it's like held in with magnets. Actually, I'll stick it on real quick if I can. Grab the right one here. I believe it's this one, because that's nice and clean. But there's big vents on the side, so I don't think those big fans that I just added in will be starved for oxygen or anything. And this one goes on top. What I'm not at all going to cover those the radiators. There's some slots in the back that could blow the warm air out well enough, but we're gonna see. Okay, so let's get this guy over here. I'm gonna scoot back a little bit. Going to screw the wireless back in. Wi-Fi 6 for when you want to be ahead of everybody to the point where you can't use it because nobody has equipment for that yet. They're getting there, and I'm really well covered in the home. I've got 2 Ubiquiti. Hear me, or am I losing power to my microphone? Hey, that sounds better. I can see the levels went back up. Thank you for that. Okay, hopefully sound is back. I can turn this bad boy on. All the fans that should be spinning are spinning. I am crushing the keyboard. And this takes a long time to boot. There's a nice little display south of this light area that has a little OLED display that tells you like the codes for where it is. It'll also tell you if things are bad, but I think we're gonna be okay. At least I hope so. Hey, there we go, video, all right. And we're into Windows, so mirror view Windows, this will be fun. But I don't have the super nice setup with the overhead camera again. And by mirror view, I mean I'm gonna have a peek in here so that we can run Cinebench again, just to watch it go very fast. It's already at the top of the chart here, but if we do, gotta make sure I don't get my hair caught in a fan and get sucked in. Computer guy killed by a hair getting sucked into fan. All right, CPU, let's run, and let's pull up Task Manager also, because it's a lot of fun to see 64 cores go to 100% usage. Nice and blue there. Well, the scene gets rendered out nice and quick, as you would expect from 64 cores doing 64 separate jobs, or 128 threads in this setup. Yeah, new case demands blood. I made the blood sacrifice the other day, actually. I sliced a finger a little bit, but not too bad. But hey, there we go, and we remain at the top of the chart here. I actually did better than the last run I did, so I don't know if that's the better cooling or something going on with the fans, but so the Cinebench score is 22,571. I have seen scores of 24,000 from other people running Cinebench. I think this is just a bit unoptimized at the moment, or maybe it's the slow RAM, unfortunately. But that was certainly nice to see. And then we can do our NAMD bench, which you're not going to be able to read because this is going to be on the command line. But we go to desktop, and then we go to NAMD multi-core, not the CUDA one. And this was, let's see, so it was NAMD 2 plus P64 for 64 cores. And then the path to the configuration file, which is in the local directory /stmv/ I believe it was stmv.namd. And science starts happening. First thing it does, as far as I can tell, is like you have one core runs to 100% as it like divvies up the job. But then many of the threads jump to, well, maybe not. Well, I guess there are upwards of 70%. They're not at 100. But it's also only about half. I still need to go in and disable the hyperthreading part of this build. Excuse me. But we've got at least half the cores at 70% or higher usage at the moment. Heat-wise, it's not bad. I could pull up the ASUS monitoring thing here, which is called Armory Crate. Let's see if it can pull the temperature. Actually, the temperature should be cycling. We're at 48 degrees Celsius on the CPU because it shows it on the CPU. How fancy. And I don't know this software very well, so I don't need to update. You must update your device to continue. Do it later. Job is still running, doing all sorts of stuff, doing all the science. And then at some point it'll spit it back out, it'll say we're done, and that'll be pretty much it. So lessons learned from this build are make sure to read the CPU compatibility chart in case there's notes about running your RAM too slow. And also vent heat upwards. It makes sense, right? Heat goes up, and this case was big enough. Initially, I thought the case wasn't big enough, so that's partly on me, but as soon as I opened it, I should have recognized. And there's clearly enough room. We've got the two big 140mm fans in the front, another one in the back, exhausting, and then these three fans going straight up. So it would also work if you want to, put your coffee cup up there, keep it warm. Don't put coffee up there. All right, most of these cores sitting over 50% or so. Still running this calculation. I don't know anything about this calculation. It's something, the T stands for tobacco, I think. I thought I saw that when I was downloading it, but it's a job that people are using to benchmark NAMD, so I figure I could learn how to do that also. But what I like the most is that the computer's on, cores are running, memory, we're using 8 out of 64 gigs, so there's a little bit of room to grow. GPU is not getting any use because we're not using the CUDA build of NAMD. But it is crunching away, and that's good to see. So definitely Cinebench knows how to use all 64 cores. I like that. But I'm not going to bore the rest of us. Well, this should be nearly done. It is done. OK, let's see here. Failed to output, blah, blah, blah. That's normal. So we are at 64 CPUs, 3.6 days per nanosecond of computation, and I think that there's some optimization that I need to do, but that's about as good as you're going to get on CPU. When I turn on this GPU, it goes down in half from there, and 3080 Ti's, I have no idea If I get a chance to run this with those, I will definitely post results. That aside, I think that's it for today. So thank you for watching. That was a little longer than I intended, but I also ramble a lot. But thanks for stopping by, Nick, especially. I want to thank you and everybody else who watches, and I'll see you later.